Most traders refer to the bond market as the smartest market, and actually it's quite easy to do many of your calculations, or all your calculations. It's kind of a steep learning curve to learn the bond market. So I'm going to go ahead and with this video try to explain the calculations we have to make. First of all, I'm going to be hanging out here on the balance sheet under liabilities, and that's where the bonds live. So I'm going to go ahead and draw something very similar to what we've seen a few classes back, the time value of money calculation. Down here at the bottom, I'll put present value, and I'm going to put $1,000. I'm going to put future value, put $1,000. And if you look, the prices are the value is the same. We refer to that as par. Let's put par here. That's also face value. So you kind of see if you loan money to an organization at a predetermined future date, number of payments later, you're actually going to get back $1,000. So in essence, no capital gains. So how do you get paid? Here's the issue date. Well, you get paid based upon a percentage rate. In this case, I'm going to make it 11%. So 11% of 1,000 would be $1,100. So in essence, you get, in this case, we'll just make it a 20-year bond to keep it simple. And I could put 20 slashes here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and the 20th one will be right here. So you get and there's going to be a one each down through here. So there's going to be 20 payments of $110. That doesn't change at all. And you can see how the value of it. It's kind of, let's do a little algebra here and play with these numbers. What would you pay for something that you made $110 on and you have to have 11% return? Well, if you do this math, you divide 11% into that, you're going to get $1,000, which is nothing more than algebraically rearrange this and saying, okay, what's 11% times 1,000 is 110. So that's kind of the valuation method. That's very similar to doing stock valuation, dividends divided by RS or return, and you get the valuation of the stock. But we're doing bonds right now. Now, the issue about bonds is not what you see here. The issue is the calculations, because between this line here and this line here, what we see is that bond prices fluctuate. Now, this line is going up and down that middle line. So you can kind of pretend that middle line right here, this line right here is $1,000. So you can see a bond can trade for greater than $1,000 or less than $1,000. Now, if somebody purchases it, excuse me, at issue date and holds it till maturity date, you see what happens in between those lines really doesn't affect them. However, when we're dealing with the secondary market, it does, and this is where most of our calculations will occur. And we only really made 4 calculations. So I'm going to go ahead and I'm going to write those 4 calculations. But before I do that, I'm going to first start with one other thing to explain this. I'm going to draw a little line right here. We'll do it down here for some space. Draw a line right here. And with this bond or a similar risk bond, 11% would be the coupon, and the bond would be worth $1,000. Now, what happens is if a similar risk bond in the future is issued at a higher interest rate, we'll say just make a number up, 12%, you can see that if you had the choice between buying a seasoned bond for $1,000 or a newly issued bond for $1,000 that pays you 120 versus 110, you would never spend $1,000 on both of them. So since this one's going to be priced $1,000, this bond actually will decline slightly. They kind of have an inverse relationship between the two. And of course, you can do the opposite. Anything that falls below the 11, this bond will actually increase in value. Now, the first calculation is, and I'll leave it in green. I'm just right here. 1 is called current yield. Now, the current yield is not what an investor would receive, not what an investor would receive. It's nothing more than the annual coupon. In this case, it's $110 divided by whatever the current price is. And I'm just going to make a number up. Let's say the current price is $11.75. So whatever that percent is, that would be the percent that determines, well, that's the current yield. It's a really simple calculation. A lot of students will, when they see current yield, they'll break out their financial calculator, think it's some kind of fancy statement. No, it's not. It's not what the investor would receive. It's just the current yield for this bond or similar risk bond. Now, let's go ahead and do another calculation. Let's just do this one in red and put number 2. And I'm actually not going to do it yet because I'm going to put PV here because that's what we're going to be looking for, the present value of a bond. And I'm going to put brackets here because in accounting that means it's negative. The present value will always be negative. So if we're trying to determine what the price of these bonds are, all we need to know with present value is 4 to 5 data points, and we can get the present value. But let's skip that one for just a second, and let's go to a third calculation. The third and the fourth calculation. Oh, let's do the fourth one in a different color. And the fourth calculation is nothing more than a rate. This rate right here. So let me go ahead and get back to blue. So I do this right here. And we're going to calculate both of them in just a second for this bond. I'm going to make up a number. Let's start with the this rate here. Let's say that this bond has 10 years left to maturity, and it's currently selling for $11.75. I'm going to go ahead and put my brackets here because it's negative. So let's go ahead and count back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're right here at the 10-year mark. 10 years in the bond, 10 years left. The current price of the bond is $11.75, and we know our payment is still $110. We're going to get 10 more of these payments because we're 10 years into it. So my N is 10, and we have our future value. Our future value is going to be the $1,000. So if we take a look, we have all the data points we need for our, as we refer to it, as our yield to maturity, because yield is rate, and we're going to have the rate till it matures. Now the neat thing here is, you see, look at this just for a second. If you were to pay $1,000 for something to only get back $1,000 and get $110 every year for 10 years, your return's 11%. However, since you paid an additional amount for it, this sucker is going to depreciate. You're going to lose $175 over 10 years, so you have to account for that loss somehow. So if you put in your calculator, or if you're looking for an Excel rate, all you have to do is put in PV is negative, N, this, and this, and you will get, I believe if I did it right, 8.35%. And that would be the rate that a investor would receive. So an investor that purchased this thing for $11.75 and held to maturity is going to receive the 8.35 annual return. Now let's look at another calculation. This one I'm going to call yield to call. Now yield to call is basically many bonds will place a call premium. That means they may call them early. And they do that with the hopes or the thought that in the future these rates will drop to a low point, allowing them to call them early and then reissue more bonds at a much lower interest rate. So let's say there's a call premium at the 15-year mark, or 5 years from this purchase here. So this we buy here. So we'll go ahead and mark out. We'll come 1, 2, 3, 4, and I think that would be the 5th year. It's kind of hard to see. So we got 5 payments here. So again, here's our payment, same payment. Now we're not getting 10 payments. We're getting 5 payments because it's going to be called 5 years from now. This is still the PV. So we have the payment and this being present value, number of payments, and payment. Now, we also have to remember a lot of times that this, when we call them early, we have to pay a little extra. How do we do this? Well, let me just go back for just 1 second and show you one little neat thing, little trick. Bonds on the bond market are listed as a percent of face value. So this bond would actually be listed like this on the exchange. So it says it's trading at 117.5% of face value. So 117.5 would be $1,175. So a lot of times when we have a bond that's going to be called, we usually call it for a little extra. For instance, this one may have a call provision that says 5 years remaining till maturity. I can call it at 109% of face value. So if that's the case, I have to call it at 1,090. So that's our new future value. So we just place this in the calculator. We'll find that there's present value, negative. There's future value, positive. There's the payment, which was set on the original coupon, positive. And there's how many payments you'll get. And if you put all those in, your rate, I believe, should be 8.13%. If I did it earlier, correct. Now here's the fun part. Which one would you rather have? Well, I think most people would agree that if they could invest, they want to make a higher return. However, since the company's in charge of this, they're going to pay you the lower return. So this bond will probably be called. Now let me go ahead and pull this down and get a little bit more room here. I haven't done present value yet. Well, let's put it right about here. And you go ahead and do present value. Present value is nothing more than finding the present value of two things. Well, remember what a bond is. A bond is a series of annuity payments and a future value. So what you're really doing is you're going to discount them back at those rates. So for instance, let's pretend like, and in red, we did not have this number here, and this is the question mark. The question mark, what would you pay for these two individual bonds? Well, we have the new rate here, which is the yield to maturity and the yield to call. So if I were to ask you what the present value of that bond would be, and you calculate these two problems again, except in your calculator you're looking for PV, which means that becomes payment, that becomes future value, that becomes number of payments, and that here is the rate, you will get 1175. And if you do the same thing using this rate here, instead of using the numbers I just checked, use the same payment, but now use 5 here, and that number, you will get 1175 again. So the present value is nothing more than really nothing more than the present value of a bond. So I hope that helps a little bit with bond valuations, and see that you're really only calculating really 3 calculations. Now, I'm not going to do duration on this one. Duration is a little bit tricky, and I have another video on duration. Duration basically looks at, okay, for every % change this changes, how does that affect the bond's valuation? Let's do one more thing. I'm going to pull this thing down. Oh, went too far. Let's stop right here. I'm going to talk about risk for just a second. I'm going to do it in red. It's a good color. Bonds have 2 risks that the textbook will talk about. The first risk is called a price risk, and the second one is called default. I think default makes complete sense. The company goes bankrupt, you get pennies on the dollar. So if this company went bankrupt, you may get $200 for every one of your bonds, so you lose $800. The other risk is called price risk. Now, price risk I'm going to break into 2 parts. Now, price risk, you've just experienced one of them. You saw how the price changed. We call that interest rate risk. Interest rate risk just basically showed that when the rates go up, the bond valuations go down, the opposite. And the other risk is called reinvestment risk. I'm just going to put I'll just go ahead and write it. Reinvestment risk. They're mirrored images of each other. So if you know one, the other's the opposite. So I'm going to come with this interest rate risk. I'm going to go back up to our picture and show you interest rate risk. Well, interest rate risk is these large swings. So I'm going to use this red. I'm going to show you even a larger swing in prices. Remember that center line was $1,000. So you can see the red had a greater price swing here. It's not perfect here than the green. Well, the first thing you should see apparent is that the farther you're from maturity, the larger the price swing is. So the larger maturity dates, so I'll just put in larger, you're going to have much larger swings in value of the bonds. The second one has to do with this little coupon here. The smaller this coupon is, the less it can absorb these changes, therefore it all gets placed back on the price of the bond. So when you have very low coupons, or I'll just go ahead and put right here, are low, you're going to have very large swings in the value of a bond. So you come over here to the reinvestment risk, it's the opposite. Small or close to maturity with high coupons. So I hope this helped a little bit understanding bonds. Kind of a busy screen there.